Hi everyone, this is Hussein Ergin. Welcome to our talk. Today we're going to talk about some important research to make MDE more available to students of all ages and will most likely lead to maybe a vision for MDE for all. So let's start. Of course, to proceed, we first need to understand why computer science education is so popular recently because there is this push to make progress in every frontier. Of course, given the importance of computer science and programming today and in the future, it's normal, and code.org is one of the main venues that makes this push around the world with its activities and environments. So, however, we have a problem in MDE. So, the way code.org does this is fun. Okay, so there are puzzles, there are themes, etc. There are browser-based stuff. So it is fun. But most MD education either starts as an undergraduate as elective courses or graduate specialization. So we are not introducing MD earlier than this. This is a big problem. And for a technology that's claiming to raise the abstraction in programming, it doesn't sound good if we don't introduce ourselves as a next step to the current programming paradigms. And young generation doesn't even know MDE in the way that we want them to know. Some of them see UML, of course, in a very basic sense, but from K through 12, which is before higher education, they do not even hear that. So we don't provide them any exciting environments like the code.org provides. So in block-based environments, of course, they utilize the benefits of visual programming, okay, the blocks and stuff specifically to train new generations of computer scientists. However, these efforts focus on imperative styles of programming, so the loops, conditionals, variables, or these kind of stuff, just in a visual way. So the things that we have invented maybe 40, 50 years ago, but in a visual way. So we thought maybe we should combine these two fields, model-driven engineering and the block-based environments, so that we can provide the alternative MDE structures to the to the traditional imperative programming structures. And the first step to make the introduction is, of course, to make the MDE earlier in the programming education. We should maybe introduce them very early on, like even before higher education, even while they're in elementary school. And we should provide it as a real serious alternative to the traditional programming. And this is the core idea of our vision paper. And this presentation will talk about how we're planning to do it. And of course, there are, if we want to be a serious alternative to block-based programming environments, first we should discuss some key characteristics of a possible alternative MDE-based environment to serve to K through 12 students. First, similarity to the BBPLs. So more than half of the students in the US, and there are lots of students overall in the world that knows how to use a block-based language. Okay? Dragging and dropping. Of course, it's straightforward, but however, they got used to the idea. Okay? Therefore, our environment should be similar to BBPLs, basically, block-based programming languages. And it should be visual. Visual versus textual has a lot of studies in engaging new learners, and visual has obviously lots of advantage. Therefore, we should provide some kind of a visual environment. We cannot provide some textual environment and expect to be adopted immediately. And declarative model transformation should be supported because this is what we see the most common way of providing some semantics to static models, because eventually we will provide some semantics, some movements, some dynamicity to the models. And of course, this will also make the transition after block-based languages easier to the model transformation or model-driven engineering. Also, it should be easy for first-time early learners. So we should not provide them like our very famous complicated modeling tools. We should provide them simple tools, simple environment, as simple as using a crayon. So we shouldn't clutter the environment basically. And it should be web-based. So this is a must, of course, for any modern software environment. We don't need to install it on computers. It should be web-based. Also, this has an importance because given lots of students before higher education, uh, some of the students have access to Chromebooks only. Okay? So that means they cannot run anything other than a web application. Therefore, it is important our tools should be also support web-based. So we started modeling our environment, and this is just a screenshot of it. We are going to discuss what are the details. Of course, each part of the system should be modeled. So this is the instance model where we provide the screenshot of the puzzle to be solved. And this is the transformation part of the model on the right-hand side to solve the instance model, basically. And on top, these are the elements that we can drag and drop and we use in the rules and you want to create instances. And each part should be modeled. That means they should have their own meta model and their own concrete syntax, right? So this part, the maze part, should have their own meta model, the pigs, birds, the tiles, and everything, and how they look like. And the transformation part, again, it's its own meta model in our system, and they have their own concrete graphical syntax. And now let's see how to solve some of the puzzles in traditional block-based systems versus our new environment. So this is the first puzzle that's being taught to the students. So basically the idea is just move the bird 2 blocks south and then it will catch the pig. And of course, in order to do that, you just drag and drop, move forwards 2 times. That's pretty straightforward, right? And here, how our region looks like. So we just create a rule with pre and post condition, saying that this rule will move the bird 1 block south, okay, 1 block down, and we will execute it 2 times. So this is how it is, and actually, as you see, we are not just giving them blindly what is a block. We are also trying to provide them what the block does under the hood. Okay, and to model it as a pre and post condition is actually very straightforward. And it also makes them understand more what's happening under the hood. And of course, we can even model the built-in rules. For example, in this system, when the bird is on the same cell with the pig, it catches automatically. Okay. We can do this, or we can say we can provide them as a rule as well. If they're on the same cell, catch the pig. So just lose the pig and on the right hand side, right? So this is possible, and this is the solution of the exact same maze with built-in models, built-in rules also modeled. Yeah. And more examples, of course, in the paper. We have several other mazes in the paper and several other more in this web page, which is also referred in the paper. So we believe this intersection between MDE and computer science education is full of opportunities. Okay. Best of all, it is still unexplored territory, and there's a lot to explore what's going on. And here we are going to talk about some precursors. So the first one is empirical and evidence-based pedagogy. Basically, we have to understand how the students will approach, how the students will learn from our MDE environment versus the traditional block-based language environment. Because the idea is similar. We want them to learn computing, okay? And that's why we have to compare some in some empirical studies. Some groups will focus on block-based, some groups will focus on MDE-based, etc. This is one of the steps that we should do. Another vision is minimizing the footprint of the MDE tools. We know that MDE tools are not user-friendly for non-technical end users. That's for sure. And most tools, by research, can be a source of the problem when incorporating new systems like ours. So we don't want a tool to block the usefulness of our MDE tools, of course. That's why we want to solve technical problems as much as possible, and we don't want them to be showstoppers. Another research vision is student customization of the worlds. So that means students should easily add some new environments. In code.org, there are tens or hundreds of different platforms from Maze to Angry Birds to Frozen, etc., all themes. So we should be able to do it, basically. So our environment should be able to let this. That means we can create new meta models with new concrete syntax, and here we have the new environments. And of course, we have to also look for alternative transformation approaches. We have opted for explicit scheduling declarative rules with separate pre and post conditions. But there's still a lot to explore. So what is the effect of implicit scheduling? How about layer-based scheduling? So the rules with combined pre and post condition because our rules were separate pre and post condition. So there are lots of stuff in the model transformation taxonomy that we can just try to understand what is the effect if we will incorporate them. And the last research vision that we can show is the puzzle structures and progressive learning. So in the traditional block system, of course, they are just given an instance and they are expected to create some kind of a flow of the solution. So this is possible. So we can give the instance on the left hand side, we can on the right hand side, they can solve the problem with the transformation. Or they can do the vice versa. We can give the transformation and we can expect them to create some kind of an instance that can be solved with this transformation. This is possible. Or we can just give the scheduling of the rules and we can leave them empty so that they can just drag and drop the patterns. Why not? Or they can totally create their own systems by creating their own meta models and they will create their own puzzle environment. Why not? So the opportunities are endless if we want to focus on this. So this new intersection is full of opportunities as a conclusion. And we believe it's a solution to the marketing problem of MD, and this will also trigger an interest in the modeling among the CS education community. Also the same effect in the CS education among the modeling community. So it will like the merging of these two communities. This will also teach abstraction starting from the younger ages. We already have a prototype, of course. We are trying to make it ready for an initial empirical study for K through 12 students in this spring. But that's all I can say at this point. Thanks for listening, and I can answer any questions now.